All right. Well, it's a little past 7 here. We'll get going. I appreciate everybody tuning in and want to get into our speaker's topic shortly, but there's a few housekeeping points I wanted to make just so you're aware. Your video and your audio is disabled. We're recording the talk, so the lecture will be available on our website too if you wanted to view it again in the future or direct people to watch it. It's a great way to keep conservation topics fresh in people's minds. We uh, we started the lectures many years ago, and they were in person, and now we are doing them virtually. One of the reasons is the pandemic got us to switch to this mode, but it's really nice to have the recording capability as well as reaching out to different speakers that may not be able to make the trip. So we're really happy to have that. Uh, We'll have about 45 minutes of presentation, followed by a question and answer period. It'll be maybe 10, possibly 15 minutes, sort of depends how things go with the talk. The chat, if you have a question, go ahead and type it into the chat, and we'll curate the questions here once the speaker is completed. And additionally, in the chat earlier on, if you're new to this and just discovered it through some social media aspect, you can send us your email address, and we can add you to our future lecture series emails and communications. Last month we had polar bears, which was a great topic, and it's available on the website. So without further ado here, we're real fortunate to have two really significant conservationists associated with Guatemalan wildlife, especially the reptile side. I'll start with Dr. Brad Locke, who is a grant recipient from our conservation grants program for a number of years, and his work is focused on Central America. We're real fortunate to be able to present a grant recipient's work. We're really proud of the grants we provide, and it's great to see the work that's being done. Brad has been involved with conservation of wildlife in Guatemala for over 20 years. Brad graduated from the University of Florida College of Veterinary Medicine and completed a residency at the University of Florida, as well as being board certified in medicine, zoological medicine, and has been in a number of institutions. He is one of three co-founders of Fundasqua, which is the Foundation for the Conservation of Endangered Species of Guatemala. He founded that with two other colleagues in 2014. And currently, he is coordinator of Guatemalan conservation programs at the Oklahoma City Zoo and Botanical Gardens. So Brad is much more familiar with our speaker's work and obviously the topic. So we have Thomas Shri, who is the Guatemalan biologist that's going to be presenting, and the field director of Fundasqua. So Brad will detail a little bit more about Thomas, as well as the work that he's done with Brad on one of the rarest lizards in the world. Go ahead, Brad.
All right. Thank you, Dr. Kapustin, and good evening to everybody. I'm really happy to be able to present our work. And like Dr. Kapustin was talking about, we've gotten a number of grants from Greenville Zoo, and those are all very critical. All grants are very critical to what we do and what we're able to do. So I'm going to read quickly what Thomas sent, or what his bio was for this talk. Thomas Schrei is a Guatemalan biologist and field director of the Foundation for the Endangered Species of Guatemala, Fundesqua. His work focuses on the conservation of threatened reptiles through field research, habitat protection and restoration, and environmental education. As part of Fundesqua, he works with local communities and international partners to develop long-term conservation strategies in Guatemalan forests. And all that is right. And all that is correct. But he's much more important than that to Fundesqua and to the conservation of forests and species in Guatemala. Um, I started there in 2005. I probably met Thomas about 2008 or 9. He was a college student at the time, and we worked at a different group. In 2014, as Dr. Kapustin mentioned, when we decided to branch off to our own foundation, I brought along the two people from that group that I thought really aligned with my idea of what conservation is and what real long-term achievements are, and that was Thomas Schrey and Monica Torres. And so those two people formed the three people that did the original foundation. Since then, that has gone from a species-focused program, the Guatemalan beaded lizard in the dry forest habitat, and Campbell's alligator lizard in the more pine oak, elevated, higher cloud forest type habitat. And it's gone from, like I said, species-focused to habitat-focused. So, and Thomas has been critical in that with reforestation, community involvement, and government interface. Without him, I don't think we could have progressed as far or as fast as we have. So I just want to make sure that everybody understands that. And he has been a part of this group for that whole time. And through a lot of discussions and some arguments, we have gotten to where we are, which is beyond anything I ever thought in 2005. So with that, Thomas, I'll give it to you.
Okay, thanks, Brad. Thanks, Nikolai. So let's start by imagining we are standing in a forest. It's cold, it is humid, and we look up and we see the clouds. These clouds are moving with the wind, but the clouds are not above the forest. They are moving through it. They are moving between the trees. This is the Guatemalan cloud forest. Each tree is an ecosystem on its own. There are dozens of other plant species living on each trunk and branch. There are mosses, ferns, orchids, bromeliads. And within every tree, there are complete food webs. And at the top of this food web, there is a predator. There is a small dragon. It is one of the rarest and most difficult to find reptiles species in the world. And sadly, it is one of the most endangered. It is a species that is fading into the mist. Today, we will talk about this dragon. So let me introduce you to the Campbell's alligator lizard. So this is the dragon. This is a Abronia campbelli. It is a species that lives almost its entire life in the trees. It is hidden in the canopy, is nearly invisible. And for decades, very few people had ever seen one in the wild. And yet, its world has been disappearing tree by tree. So my name is Thomas Schrey, and for over 10 years, I have worked with this in this forest, studying and protecting this fabulous species. I represent a team of dedicated conservationists, Dr. Brad Locke and Monica Torres, and also the field personnel that make this work possible every day. Together, we are the Foundation for the Endangered Species of Guatemala. We work along in partnership with the Oklahoma City Zoo and Botanical Garden. And we are deeply grateful to the Greenville Zoo for inviting us to share this story, to be part of this conservation lecture, and most importantly, for supporting this project and many others over the years. And I also want to thank you all for being here, and especially for caring about conservation. We'll have some time for question at the end, so prepare your questions. I'll be happy to answer them, and I look forward for this discussion. And before we can understand how to protect this species, we need to understand how it lives. So we will do this in this presentation, but this presentation is also about that, about how we need to understand how a species lives before we can take decisions about it. So let's take a closer look at the natural history of the Campbell's alligator lizard. So Abronia campbelli, it is a predator, as I said. It primarily feeds on insects, but it can also consume small vertebrates. This would be other lizards most of the time, and occasionally even babies of its own species. But what is most striking about this species is that it is arboreal. It is highly adapted to life in the trees. And one of the most distinctive adaptations that it has to live in the trees is their tail, the tail that they use to grip branches and to move with confidence through the canopy. And this raises an important question. Why living in the trees at all? What advantage does this lifestyle in the trees provide? So to answer that, we need to step back and look at the geological and evolutionary history of the species. So Abronia, they evolved during a time when dense cold forests were far more widespread across the continent. These ecosystems were very humid, very complex, very dense, and shaded. And we know that reptiles are ectothermic. This is what we often describe as cold-blooded, which means that they do not generate any significant heat on their own. So they depend on external sources for warmth. And this source is primarily the sunlight. However, in a dense forest, there's very little sunlight reaching the forest floor. So this created an opportunity. If a reptile could move upward into the canopy, it could access light and warmth and occupy a new ecological space for reptiles. And this is exactly what Abronia did. They've evolved to live in the exposed portions of the trees, and here they harvest the sunlight above the shaded understory. So this made them remarkably successful within the ecosystem. However, these days, the planet is going into a warm period. We are not at a glacial age. So these environments, these cold forests, they persist mainly at high elevations, and they currently are restricted to the top of the mountains. So let's actually see the lizard. Here's a picture. Look at the eyes. They are alert. They are focused because they are predators. They are always watching, and they are always ready to strike. And if we look at their head, you can notice the scales. They are thick, and beneath them in the skull, there are even some bony plates that provide some additional protection. So they are fearless hunters, fearless predators. Their head is reinforced for that role. And when it comes to colorations, well, the coloration basically mirrors the forest itself. They look like lichen, moss, wet bark. So at a distance, they disappear. And we're going to see in this presentation how difficult it is to actually see them. So that's the reason why they are so difficult to study. And they are a bit small, maybe one foot with their tail, but they do not behave small. When threatened, as we can see in the picture, they make their intention very, very clear. They open the mouth, they stiffen the body, they elevate the head, And this is a clear signal to do not come any closer. And if you do, here's the result of that defensive display. And when they bite, they really commit to that bite. They lock their jaws in place. And to release them, it takes time. So handling them requires patience and experience. And even then, you get bitten pretty frequently, and it hurts. Here we see the tail. It acts as a fifth limb that allows them to grip branches and to move securely through the canopy. However, when they are threatened, they can shed part of this tail as a defensive reflex. We call that, the process is known as autotomy. This is pretty common in lizards, and it is very common to find abronians that had lost their tail. They are able to regrow their tail, but that means that they are getting into some aggressive behavior during their life. So we are becoming familiar with the species, but I need us to look back and look at its history. This species, it was only discovered in 1992. So that's not a century ago. That's within many of our lifetimes. So for most of history, we didn't even know that this lizard even existed. And from the very moment that it was described in 1992, the authors were already raising concerns about their conservation. Let's look at what they wrote at the end of that scientific publication from 1992, where they described this new species to science. This is the exact final paragraph of that paper. They estimated at the time that the species range was only about 4 square kilometers, that's about 1,000 acres. And they end, because this is the last paragraph, they ended the publication with this sentence. It says, "This spectacular, newly discovered lizard may soon become extinct." So they raised the alarm in 1992. But for nearly 2 decades, there was no response, no action followed. It was until 2012, this is 20 years later of that call, when my colleague Monica Torres and her team returned to these mountains. And they were looking to answer a simple but very urgent question. Was the species still there, or has it gone extinct? Has Guatemala another extinct species? Because we have a few already. And after days of searching, they eventually located a few individuals. It took a few expeditions, and there were some individuals clinging to old isolated trees. And what they also found was a severely transformed landscape. It didn't look good for the lizard. But there was hope, because once believed extinct, it was still there. So let's look at how this area looked. This is the exact location where the species was first discovered. That was once a forest with very, very large oaks, where the original discoverers that they could climb and collect these lizards. But today, there are barely any trees in this area. It's now reduced to a handful of scattered trees, and these trees are mostly pines. And these pines are just part of a managed system. They will be harvested for timber once they reach certain size. So the reason why it looks without trees right now is because they had just harvested the pines. So they are regrowing pines again, and they will be harvested again. Here we see a broader view of the landscape. This is the area surrounding the original discovery site, and it is now dominated by agriculture. So there's farmland, there's pasture, there are poultry farms, pig farms, orchid greenhouses, pine plantations, avocado orchards, coffee production. There's nearly every possible land use but almost no natural forest. So as a result, there's very, very few remaining trees suitable for abronia in this area. And we have spent the past decade trying to develop a much clearer understanding of where this species might persist. We have gone well beyond the original 4 square kilometers that the authors thought was the natural range for the species. And we have found it somewhere else. We have found some from other small forests holding the species. So that's what makes this conservation journey very helpful. But let's look in detail at their current distribution. So here is a map of the Americas. We can locate Guatemala in the middle. However, this species is unique to Guatemala, but that doesn't mean that it occurs throughout the country. It is restricted to this tiny portion that we see in red in eastern Guatemala. This is an isolated mountain range that we know as Potrero Carrillo. And although it is bigger than 4 square kilometers or 1,000 acres, we need to look at its current state. So here is what it looked like. Even within this mountain, forest cover is extremely limited. We estimate that only about 3% of the area can still be classified as natural forest. And even those remaining patches of forest, they show varying levels of degradation. They are not intact, not near close to intact. These forests are not functioning at full ecological capacity, so they don't hold as many abronias as they should if they were intact. They are not. But in these areas that we know very well is that we still find the species. However, it is scattered, it is degraded, it is fragmented, so it has plenty of conservation problems. And as a result, the species has been evaluated by the IUCN. This is the International Union for the Conservation of Nature. They evaluate all the species in the world about their risk of extinction. And for Abronia campbelli, it is considered as critically endangered. And this is the highest risk category before being extinct in the wild. So our goal, our mission is to reverse that trajectory, to gradually downlist this species from critically endangered to endangered, and then eventually to a category where it is no longer at immediate risk of extinction. So that's our mission. And here in this picture, we have a better look at the current state of the habitat. So what we see is not forests, is isolated trees. They are widely spaced across a heavily altered landscape. And most of these trees, they are very, very old trees, hundreds of years old. And many, if not all of them, at least in this area for the picture, host Abronia individuals. But they are gradually disappearing. Some of these trees fall naturally because they are very old, but some others are cut down. And when the tree is lost, the lizards have nowhere to go. They could go to another tree, but that tree is already at capacity. It is holding all the Abronia that they can hold. So there's no space for them. So as these trees disappear, the lizard also disappears. We need to focus on trees. So this species requires urgent conservation action. And since 2012, this was the year of the rediscovery of the species, we launched a comprehensive conservation program around it. Our conservation strategy, it really begins with awareness. For many years, the local communities had very limited information about the species, mostly because they can rarely see them. And also what they did know was often based on myths and misinformation. Some believed the lizards were venomous, and as a result, people would kill them on sight. At the same time, the local authorities and agricultural producers and business owners, they were not aware at all about that this species existing at all. So this created a serious barrier to conservation, but we have worked to change that. In this image, you can see one of the educational activity books that we have developed and distributed to local schools. Education is a central pillar for our program. We work especially with children because we believe that long-term conservation depends on a cultural change, but we also raise rich adults through other means. And here in the picture, you can even see a boy holding a snake. This is part of a broader effort to build respect and understanding for reptiles in general. And it is working pretty good because now people, they know the species, they know that it is unique to their mountain. So it's a source of pride for them, and they all want to preserve it. And they have learned that it is not venomous, although they can be a little bit aggressive. Habitat restoration is another component of our strategy. So we are currently producing more than 35,000 native trees per year, or seedlings. To date, we have planted over 170,000 trees. And these are locally sourced species. We have selected these species because we have learned from research that these are the species that the Abronia needs for survival. They don't use any tree, or something that has happened is that when people want to reforest or to plant trees, they don't know which is the correct species for the native landscape. So they will plant exotic species, and native fauna is obviously not adapted to exotic species. The picture that we are seeing, that's our tree nursery where we produce this 35,000 seedlings per year. We have 3 team members working here full time to sustain this reforestation effort. But when it comes to actually planting the trees, we don't do it alone. We do not work alone. We partner with local communities, with large land owners, private companies, business owners, that they help plant and care for the trees. So this level of participation that we are seeing in the picture is the result of sustained awareness and trust building that we have worked over the years. And it is evidence that conservation in this area is no longer an external NGO doing stuff. It is shared with the local people. And just like you and me, local families and even business owners, they can be conservationists, and they are conservationists. So we can see here members of the local community unloading seedlings from our truck to plant around their village. We always say that conservation succeeds when it becomes local. And this is what we are doing with this awareness work and with this community engagement work, making conservation local. Research, it is also a fundamental part of our work. When this species was discovered, it was almost completely unknown. And Abronia, there are several species of Abronia, but in general, they remain among the most enigmatic reptile group. We don't know anything about any of the species. So there's still much that we do not understand. So from identifying the last remaining forest fragments to strategic planning of restoration areas, we really do rely heavily on scientific research. We also conduct extensive drone-based mapping. This allows us to assess the habitat condition and landscape connectivity. So we have got a much clearer understanding of the conservation status of the species and the things that we can do to save it from its current path to extinction. So let's return to this image that we saw previously. because this illustrates the challenges pretty clearly. There's no continuous forest. There's only scattered, isolated trees. So, okay, let's plant forests. It doesn't work that way because restoring forests is not that simple. People's livelihoods depend on the land. There's very large companies generating revenue from the land, and people's livelihoods depends on them. So there are very strong economic and social incentives to maintain production. So there's no simple way to stop that. So instead of opposing production, we work to make it compatible with conservation. So what we need is a strategy that can make conservation coexist with people's livelihoods. And so we are in need of a strategy for that. So our strategy in the area, you have seen all the trees that we are producing. So where do we plant them? So our strategy is based in that these properties of various land uses, various owners from local families to multi-million-dollar companies all have something in common. And is that they have boundaries, they have fence lines, they have road margins, riverbanks, or areas that remain underused due to topography or any reason. And for us, these spaces represent opportunity because this is a small arboreal species. So linear corridors of trees could potentially function as habitat and provide connectivity between the remnant forest patches that we have found. So if we could reforest the fence lines and the roadsides, we could dramatically expand available habitat. It won't create intact forest, but it creates connectivity. And connectivity for a species globally can mean survival. So all these trees are being planted without excluding anyone from their livelihoods. But this raises an important question. Are Abronia going to use the planted corridors? And under what conditions would they do it? Because it might not be enough to simply plant trees to actually provide habitat. It depends on the Abronia being able to use them. So they might need specific characteristics in these corridors. Maybe a simple row of widely spaced trees would work, but we need to verify that. So in order to Abronia to use the corridors, they will need to find the right conditions that allow their natural behavior to reach these areas. And this will really depend on how they move and where do they move. So we'll see, here's a conceptual scenario that we are investigating right now. This is because many reptiles exhibit very limited dispersal capabilities from their birthplace. They tend to live very close to their birthplace, and they do not expand rapidly across landscapes. So this means that movement for a reptile could take generations. It is not. In this illustration, we show a corridor of only 300 meters long. But if the dispersal radius is only 50 meters per generation, it could take up to 6 generations for the species to reach to the other side. And that's assuming that the corridor has actual suitable habitat at every step. So what we need to know is how much do they move. That will change things. And what constitutes suitable habitat? Because unless our corridor looks like good habitat to them, they will not use it. Also, they are not going to use the corridor to cross from one suitable forest to another. They will need to spend their lifetime in the corridor, and it will take several generations to reach the other side. So corridors are not simple rows of trees. We really need to verify that they can be and will be used. So we realized that we needed to study the species much more closely. remember that much of this basic ecology of these lizards is unknown. So in order to answer these questions, we turn to radio telemetry. And with radio telemetry, our first challenge was pretty simple in theory. In the picture, we see small radio transmitters. And how do you attach these radios to this small arboreal lizards? So at first, it seems pretty straightforward. But believe me, it wasn't. And we tried everything. So it turns out that abronias are remarkably slick. And we quickly realized that they are slick for a reason. So they move through dense vegetation, branches, mosses, epiphytes, very narrow spaces. So pretty much any modification that disrupted their streamlined body increased the risk of them becoming entangled in the vegetation. So when we began the project, the abronias were getting entangled, and it was dangerous for them, and that was unacceptable to us. So we had to suspend the study until we could demonstrate to ourselves that the transmitter could be attached safely and that it wouldn't compromise the animal movements at all. So as it is often the case in field biology, the simplest solution proved to be the most effective. We developed a method that uses a special waterproof duct tape that is so special that it is available at any hardware store. And we secured the transmitter with the tape to an anterior portion of the tail. And this location has worked pretty good. It's not that easy as it looks. It took several ways of doing it in order to reach what we are showing here. And this is what the final attachment looks like. It is very critical that the tape applies no pressure at all. We found that if any pressure is applied, the lizard may shed its tail. So during early trials, we experimented with some slightly elastic tape. It looked pretty nice, pretty clean. But the very first individual that we tagged autotomized his tail. So that sent us back to the drawing board for the millionth time. And it took further refinement, and eventually we developed this method that we see here. And it has proven reliable. It is working pretty well, although it does have one limitation we're going to see. So the limitation of this method is that abronia, they shed their skin. What we are seeing in the picture is a shed. So unlike many lizards, they shed their skin in a single piece. So almost like if they were snakes. And this is how the shed looks like, but you might be wondering what happens when the abronia sheds its skin while carrying a radio transmitter. So let's take a look. Here's a picture, and no, this is not a dead abronia, it's a shed skin. What happens is that the radio transmitter is still inside because they shed their skin almost like removing a sock. So the transmitter remains trapped inside of the shell. Here's another shell. We can take a closer look at this part, and we see a little bit of the duct tape. And if we go to this area of the picture, we can see the shape of the head of the abronia and the antenna of the radio transmitter. So yeah, this presents a little limitation. We really cannot warranty tracking the same individual for like an entire year. However, their shedding interval is actually relatively long. So they appear to shed approximately like every 4 months or more, which for small reptile radiotelemetry studies is a substantial duration. This is longer than the vast majority of the studies that are available. More recently, we are trying to refit the transmitters before we anticipate a shedding period. We still need to evaluate if this actually works. But perhaps the most important point of this is that if the lizards are shedding normally, we can be very confident that the attachment method is not interfering with them. In other words, the transmitters are safe, and we can continue the study. And this took many, many iterations, but we finally made it, and we can continue the study. This is the equipment that we use in the field. So it is a directional antenna that looks like this. And also there's a radio receiver that looks like that. We normally use a shorter cable, but we have several sizes depending what where you're doing. And let me explain you how it works, how the radio telemetry works. So it is relatively simple. So the antenna is directional. What this means is that when it is pointed towards the transmitter, the signal becomes stronger. And if you point it elsewhere, the signal weakens. Distance also matters. So as you move closer, the signal increases. And as you move farther away, the signal decreases. So signal strength varies with both direction and distance. So you are able to adjust the sensitivity of the receiver. So as you approach the animal, you gradually reduce the receiver sensitivity to keep refining your position. And it is not perfectly precise. It takes experience. You become increasingly accurate. But basically, you walk closer, you refine the direction, you lower the sensitivity. The signal becomes too strong to actually detect the direction. And the goal is pretty simple. You want to narrow down the location until you can visually confirm the lizard. However, at very short distances, the antenna is no longer directional. So when you are close to the radio, you know you're close, but you have no way to tell from the antenna where the radio signal is coming. But you know you're close. So this is a protocol that we follow to collect the data. So we begin by returning to the last known location of each lizard. And from that previous known location, we scan the area for peak signal strength. Actually, most of the time, simply arriving at the previous tree already produces a very, very strong signal. So we work from there. And we work as a team of four persons to actually confirm the individuals. And even being 4 persons and we being at the correct tree, it can take up to 1 hour to actually find the lizards by using binoculars. Sometimes we climb the tree to get a better angle, but it takes a while. But over time, we have been improving. Our eyes have become trained, and you start to anticipate where they might be, which branches, with epiphytes, which angles of exposure, angles in order to better see them. So eventually we confirm the individual, and only when we find it is that we record positional and behavioral data, and basically everything that we could, every data that we can take from that observation. If they are in a bromeliad, if they are in an orchid, if they are just in a branch, stuff like that. And I'll show you some photographs so you can see what we actually encounter in the field. So here's a bromeliad, and inside this bromeliad there's an abronia. You can barely see it, and this difficulty is not accidental. They don't want to be seen. But here, this is important. So for years we have known anecdotally that abronia use bromeliads as refuges, and we have created these theories that they obtain water there, that they find prey there. But until now, those ideas were based on observations and casual observations, a little bit of intuition. Those are pretty much stories from the field. But now we are moving beyond anecdotes because we are collecting systematic data. So we will be able to quantify how often they use bromeliads and under what conditions. and eventually tell how important bromeliads are truly for how important they are actually for the species. So it is that shift from just casual natural history observation to measurable ecological data that is critical. It's a critical step for conservation decisions. So let's zoom in, and here's a close-up. And if you look carefully, you can see there's a small section of the tail, and also the antenna is showing up. We're going to see another example. Here's a second example, and again, this is not anecdote, this is data, and this begins to have real conservation implications. Because if bromeliads are consistently used as refuge or as water sources, then restoration strategies cannot focus only on trees. So our biological corridors will need a structure, they will need epiphytes, they will need bromeliads. Otherwise, we could be restoring forests that they may look pretty nice, but functionally, they will lack the critical microhabitats for them. So this is becoming very relevant. Here's a close-up, and we see a little bit part of the abdomen of that lizard. Let's see a third example. In this case, the Abronia was not very high in the canopy, so I was able to climb the tree and photograph the individual at close range. I didn't want to disturb it, so the picture is not that great, but this is actually a gravid female. You can tell because the abdomen is very, very, very big. And also we are in the right season for that to happen. So this provides additional evidence that the animals remain healthy despite carrying the transmitter and despite our research activity. So this suggests that our methods are minimally invasive, or at least to a level that we can accept in order to create this important data that will have this relevance to their conservation. But we do not find all individuals in bromeliads, and at least not throughout the entire year. Especially in the rainy season, they won't be in bromeliads as much. So they are observed clinging directly to branches. So bromeliads are important, but they are not the only structural element that they rely on. Let's zoom in, and you see the lizard at the center of the picture. Another example here, you begin to realize why they are so difficult to find. So even when we receive the strongest signal, it takes the four of us so long sometimes to actually locate the animal. So here it is, right in the center. We can see the Abronia, and they stay still there, and they could be there for hours or days without moving at all. Here's another example, and here you can truly appreciate the camouflage. So as I was saying, sometimes we relocate an individual. We come the following week, and it is exactly in the same spot, the same position. Everything is the same, so it suggests that it did not move at all during that period. More often, however, individuals do change position from week to week. And this brings us to the central question of this study, which is how capable are they of movement? How far can they disperse? And ultimately, how much assistance will they require from a conservation perspective if we are restoring habitat and building corridors? Okay, we restore habitat. We want this habitat to be populated by the species, because otherwise it won't make a difference. And we need to determine how much assistance will they need. So restoration is not only about planting trees, it's about understanding whether the species can actually use the landscape that we will be creating. So let's look at a few examples of movements that we have recorded. So what we see in the picture is an isolated tree, And it's very relevant for this picture that the understory, it is pasture. And we have never, not a single time, documented movement away from a tree like this one. They don't seem to move at all from trees that have these characteristics. They are isolated, and the underfloor is pasture. And we have further proof that they are trapped in these trees, because years ago we implanted some identification tags beneath the skin of several individuals. And after 8 years, so 8 years later, we found some of these same individuals in the very same trees. So under these conditions, they appeared not to move. However, when we go to natural forest, this pattern changes a little bit. Here we begin to see movement. In this this map of a forest, we see the locations where we found the abronia over a period of 6 weeks in this case. And the location 1 is more than 200 feet from the location 2. So this tells us that the species is at least physically capable of moving substantial distances. However, in this case, the individual moved over 200 feet in a single week after a relocation event, because we brought this animal to this forest. It wasn't originally collected in this forest, and it moved. But once individuals establish themselves in a suitable area, their movements really become much more restricted, and in most cases their activity can be contained within a circle of about roughly 50 feet in diameter. So they don't seem to move that much. But we also need to look at how they move, or what they use to move. So here's another example. We see, again, substantial movement at first, followed by a much more restricted pattern once the individual settles. We have documented that they move from one tree to another through the canopy, but sometimes they also do so by descending to the ground. And in this map that we're seeing, there was no connection between the original tree and the subsequent ones, so we know that it descended to the ground. This other individual, it traveled considerably farther than the previous examples, and in this case, at one point, we located the individual in the forest floor. So this was one of our first observations of the animals staying using the forest floor. And but here, this one is most interesting. This individual actually spent 6 weeks moving along the forest floor. For 6 weeks, it didn't climb any tree, and at some point, it remained in the same floor refugee for more than a week. So these are only a few examples. We have now several months of continuous data that we need to slowly analyze. And this study is going to continue for as long as the transmitter batteries allow. So with every week, we are learning more about movement, about habitat use, about behavioral flexibility. And some of these findings carry very significant conservation implications. So let's take a look at the key ecological insights from this study. So first is that the species exhibits very limited routine movement. So most individuals maintain a home reach that is approximately like a circle, which is roughly 25 feet in radius. Another thing that we have found no evidence of seasonal migration. This means that they behave roughly the same in the dry season, in the wet season, in the mating season, in the reproductive season. We haven't seen so far any change. And this one is very, very important. So terrestrial crossings are possible. However, these crossings occur only under the right conditions. In pasture landscapes, we have observed no movement between the trees, not even rare movement, no movement at all. In contrast, in intact forest floor, the understory seems to function as a corridor. This was very significant and, for me at least, a very unexpected finding. And lastly is that individuals appear to use bromeliads frequently, particularly during the dry season. So bromeliads, they may provide critical microhabitat resources for the Abronians. But what does this mean for conservation? So first thing is that colonization of restored areas or newly established corridors by Abronia campbelli will likely occur very, very slowly. It is going to be generational. This species has very little movement and very small home ranges, so it would take generations for them to go from one side of the corridor to another. Second thing is that the corridor design cannot focus on trees alone. So we must prioritize the correct tree species, epiphytic structure, especially bromeliads, and also well-maintained natural understory at ground level. I would have thought that the corridors could be just one tree after another along the road, but now we know that if we also work on the understory with little bushes and some other small plants, that could potentiate the effectiveness of this corridor. So because without the structural complexity, connectivity might exist on paper, but not in practice. And finally, and this could be the main takeaway from this study, is that we may need to seriously evaluate assisted movement. Either we translocate adults or facilitate the dispersal of offspring, so we can ensure the colonization of restored habitats. These are not decisions to take lightly. We conservationists are always wary of these interventions, but they are questions that we must confront if we are committed to long-term recovery. And this is why we need data and research in order to be able to have the evidence that allows us to take these decisions that we must take. So the future of this species will depend not just on how much forest we plant, but actually how intelligently we design the whole conservation program. And in order to do that, we need input from research projects such as this one that is revealing a complete different picture of what someone might have imagined previously. So thank you very, very much. I'll be happy to take your questions.
All right, Thomas, thank you so much for just a really great presentation on the natural history and all the work you're doing to propagate or conserve the species. We have a number of questions. One thing I neglected to do at the outset is tell people who I am that are new or haven't tuned in before. I'm Nick Kapustin. I'm the veterinarian at the Greenville Zoo and chair of the conservation program. And I also have in the meeting our education curator, Stephanie Bradley, who's a co-coordinator on our conservation activities. So getting to the questions, why does the lizard camouflage itself? Does it have enemies like birds or other animals that are predators?
Okay, yeah, they do have enemies. They, especially hawks, basically birds of prey. They would, if they could see them better, they would totally take them all away. Actually, Abronia is one of our. So Guatemala's national bird is the quetzal, and it is famous for eating Abronias along the habitat. is not the same species of Abronia that they eat because this ecosystem doesn't have the quetzal. But birds of prey and bird predators, they are their main enemy, if you can call it that way.
Okay. What is the lizard's lifespan?
We don't know, but we know that there are potentially over 10 or 15 years. I don't know because I'm not very familiar with captive husbandry as you people from zoos or pet industry might be. However, from the field, which is a very different situation. So we have some animals that they were adults 8 8 years ago, and they were already adults, and they are still alive, and we have recaptured them occasionally. So they seem to live pretty long.
Okay.
Yep.
Very mysterious lizard.
Mm.
How long does the forest corridor take to establish, and what does the time frame for the organization look like?
Okay, so it really depends on. So initially, the problem with this tree species, the reason why they are not commercially propagated or anything is because they are slow at growing. However, we have worked in improving our seedlings, and we have discovered that if the seedlings are good enough, within 4 to 6 years, we reach a pretty substantial size. This means like 2 to 3 meters. And we have also established that we can place bromeliads artificially in this young trees. So our strategy to provide habitat to them is at least wait 4 to 6 years, place bromeliads that we are growing in another nursery, and hopefully that will be enough, or may take a little bit more, but maybe we are looking at about 10 years. But as we saw in the presentation, Abronias are not going to reach the corridor by themselves anytime soon. So we initially thought that the limitation was that the trees grew so slow that it will take time, but no. Abronias will also take a lot of time to get there. So the difference is that here we could intervene by releasing offspring in these new trees. And this is actually one of the projects for this year. It's going to be the first time that we will be releasing new offspring in recently established trees.
Okay. Let's see. What is the strategy to complete the tree's habitat with mosses, bromeliads, lichens, etc.?
Oh yeah. We have thought about the bromeliads and orchids, so we are propagating those already. We have also found that in natural habitat, bromeliads are so abundant that you can collect them by the hundreds or by the thousands in the forest floor, because with the wind they fall from the trees and they're still alive and they are going to die. So we can rescue bromeliads from the forest floor, and we have pretty much an endless supply of bromeliads to place in this newly planted trees. We believe that bromeliads are the most important to recover function. Of course, we are not going to recover the full diversity, the mosses, all the orchids, but in this, we are thinking functionally, and we believe that bromeliads should be enough, and mosses and other plants will establish themselves eventually in these areas.
Okay. Question on what does the Ambronia eat?
Oh, they are predators of mainly insects. So that would mean small caterpillars that would be very important for them. Small caterpillars and crickets. But mainly in the oak trees, caterpillars seem to be pretty important. We haven't really done a detailed study because the methodologies to collect insects from a tree at this level normally involve gassing the tree with insecticide, and we cannot do that because we would be hurting the abronia. So we don't have that high quality of evidence, but caterpillars seem to be the most important, followed by crickets.
Okay. You mentioned you had an image of a gravid ambronia, but are they egg or live bearing?
Oh yeah, they are live bearing, which makes everything much easier for us, thinking strategically for eventually releasing offspring. We have had a program for several years now because we have believed that they are trapped in these trees for since we arrived to the place, that they could not move. The adults could not move, and also we believe that these trees are already at peak capacity. So the offspring is just going to be eaten by the adults or die from lack of resources. But there's no a good chance of survival for the offspring in these isolated trees. So for a while, we have been collecting a few gravid females. At the beginning of the year, we put them in captivity until they release the offspring. Then we take the female back to the original tree, and we have released the offspring in the forests or in healthier habitat.
Okay. Is the movement to different trees part of evolutionary adaptation due to forest edge change or habitat fragmentation, or is it due to behavior?
Could you repeat?
Is, excuse me, is the movement to different trees part of evolutionary adaptation due to forest edge change, or habitat fragmentation, or is it due to behavior?
Yeah, I think it's a reasonable, really. I guess it is their natural behavior to move from one tree to another under natural forest. I would say they normally would move through the canopies. They cannot really distinguish this is one this branch belongs to one tree or this branch belongs to the other one. So they could accidentally move from tree to tree without even noticing. It's not that they want to do it. There's also another thing is that sometimes they fall from the trees because of the wind, because of the whole branch falls from the tree. So being able to move through the floor seems to be like an evolutionary need, because if that would mean that the animal dies, then that would be very disadvantaged for them. So I think they for certain have some built-in evolutionary ability to move through the forest floor. And also trees die and fell completely, so they need to be able to get to another tree.
Okay. Is the Guatemalan government helping restore or conserve the habitat?
Oh, no, not at all, but it's slowly changing at level, not at the Guatemala government, but the local government, what we call the municipality. It has recently got involved, really recently got involved into this. We have had several meetings with them recently because they are looking to declare the Campbell's alligator lizard like as the emblem or the municipal animal, if you of for the municipality, and to basically establish that the protection of this lizard is going to be a priority for the local municipal government, but not for the the national government. However, this species, it is illegal to collect, illegal to sell, and it is protected under the most strict regulations, which in Guatemala are very, very strict. The problem is not the regulations. The problem is that we don't really enforce the laws at all. We have also worked with the forestry ministry that they authorize the felling of trees in the area, and now they are starting to take into the account the lizard. However, this doesn't mean that they are not going to be allowed to cut the trees. It only means that, okay, the lizard lives here, so you can cut the trees, but you have to plant some other trees somewhere else. So it doesn't really work, but it's starting to happen. There's increasing concern about conservation among the government, and we are starting to see some positive signs.
Okay, great. It's a process, and that's encouraging to hear. Is there an estimated population count?
Well, if you go to the official IUCN website, they say something like 1,000 individuals or 500 individuals. We don't believe that. I think the current estimation is unknown, but it's certainly very, very numerous. Each tree, we have documented over 10 abronias on each tree. So you could say that the population is very, very large, especially compared to larger animals. However, they all exist within a few trees, so they can disappear from one day to another. They can disappear overnight. It doesn't really matter if there are 1,000 or 10,000 or 500 or 10 of them. You cut down the trees, and they are all gone in one day. So that's their level of risk that they have.
Okay. And I'll ask one last question, and we're almost out of time. Have you engaged any of the, I guess, the agribusinesses or farms in the area to participate in your conservation programs? You mentioned a lot of activities in that sense.
Yeah, and they actually have done a lot for the conservation of the Abronia. Actually, the land where you saw the nursery, that belongs to a large business owner, and they provide us with the area for doing our nursery. Another farm owner is allowing us to enter their forest to do this study, for example, and they have taken thousands and thousands of the trees that we produce to be planted, and most of the time they plant them at their expense on their properties, on their farms. So yeah, they are very involved, and to me it's like everyone in this area, and this has, I mean, just as you and me are conservationists, it is very, very frequent that people would say something like, this doesn't look right. There are no trees. They were harvested for charcoal in the past or whatever, but I would like the trees to be back. And yeah, I have my production in this area, but there are some areas that are not really utilized for production. So yeah, it has been actually pretty easy to get them involved, because they have conservation in the heart at some point, and they know that they control the because there are not protected areas here. We are in the process of acquiring land finally for establishing a protected area. This is going to happen in the coming months. But yeah, they have been protecting, and we have had some people actually tell us something like, "Hey, I was about to cut these trees down. I didn't know about the lizard. I just bought this farm. I didn't know about it, but now that I know, I will preserve these trees." So that happens pretty often. And also the local communities, they get involved. Everyone is involved. So it is a very positive sign for this species that despite the area being an agricultural land, but people really, really want to help.
Okay, that's great to hear that you've got that buy-in of the
Mhm.
community like that. But thanks again, Thomas, for the presentation. We learned a lot, certainly. And Brad, thanks for your hard work with Thomas and keeping the Ambronia going. For everybody that's tuned in, we do have another conservation lecture coming up at the end of March, March 26th, I believe. Check your website, and it's on the conservation of the Florida panther. And we do have, like I said, we have recorded lectures, and they are available on our webpage for lectures. If um, so, tune in about a month, and we look forward to seeing you again. Again, Brad and Thomas, thank you for all your hard work.
Oh, it's been a pleasure.
Thank you,
It's been
Nick.
a
Thank you for
pleasure.
your.
Everybody have a good night. Thank you.
All right,
Bye.
take care.